Hello students, let's work with one of the problems which is let's go some capillary here. Okay, so capillary tube of diameter 2 mm is dipped in a liquid of specific gravity. The liquid rises. This is an MCQ problem. The liquid rises in a tube. How the liquid is going to rise here? So liquid rises in tube by 15 meter. Okay, this is by 15 meter, making an angle of contact of 0 degrees centigrade. This is 0 degrees, remember. And with the tube there, determine with the tube. So 0 degrees with the tube there. Okay. So what is the question? Determine the surface tension of the liquid in contact with air and glass tube. What is the part here? Air and glass tube that we have to find. So we want to find what is the concept, what we want to find here. We want to find the surface tension. Now these are the option, 1 kg Newton per meter, 0.5 kg Newton, 0.0, more than one of above, none of above. So whatever these are the options, we'll be selecting one of them. Let's begin. So we have formula for specific gravity. Now what is specific gravity formula? What is a specific gravity here? So specific gravity, what is the definition of specific gravity? Specific gravity defines that, I'm trying to remind you, it will be the ratio of, what is the specific gravity? It is the ratio. Now if you'll consider this one, just a minute, I'll take the definition there. So let's go for a specific gravity definition first. Is a ratio of substance density to density of water at 4 degrees centigrade. So it will be ratio of substance density to density of water at 4 degrees centigrade. So on this basis, now already specific gravity is given in the question. They have given that is 0.8 for the given substance. So specific gravity, according to this definition, if you want to get the definition rho, that is density of that substance will be 0.8 into 1000. So that is 1000 related to water there. So water at 4 degrees centigrade. So that will become 800 kg. That will be kg per meter cube. That is what we are having. So 800 kg per meter cube. That is the density we are having. Now let's go for the capillary tube height formula. What is formula for height? It is 4 h is equal to 4t cos theta, since angle is there, angle with the meniscus there, upon rho, that is density, into gravity into d, that will be your, that is d. Now what is d here? If you'll observe the question, d is the diameter here. Can you see this? D diameter. Just a minute. So this is another one. This is C. This will be your diameter d, 2 mm. This is the tube diameter d, what we are considering here, according to given question. So let's continue with this part. So what we are learning, 4t cos theta. So that will be equal to 4 into t into cos of 0 there. Cos of 0 divided by whole hour. So what is density we got here? 800 multiplied by g, that is 9.8, into the diameter. I am converting mm into millimeters. That will be 0.002 meters. So this is what will be you will be having here, right? So let's continue with this. Now I'll change color for understanding here. So H, now what is the H given here? H will be equal. Now H is already given, that is 0.015. That is our H. H is 0.015 height. That is already given in the question there. So 0.015 is equal to 4t multiplied by cos theta upon 800 times 9.8 multiplied by what we have here, 0.02. Okay, 0.02. That is the diameter d. Okay, diameter, remember 4t. Already the question is 2t. Remember, it will be 2t. But since r by 2, diameter is nothing but r by 2 d. It becomes 2t. Sorry, radius is d upon 2. So 2t upon d upon 2. So this 2 gets multiplied, it becomes 4t upon d. Like that. The formula is converted in this way. Otherwise, you will get confused. The original formula contains 2t. And why we are having here original formula, just a minute. So there's no confusion in this case. Remember how I converted this formula? Just I'll use another. Original formula is h is equal to 2t cos theta upon rho g into r, the radius. So radius here, that in the place of radius, what we have, I'm taking here diameter there. I'm taking d there. Okay. So that radius will, what is r is nothing but it is d upon 2. So these two gets multiplied and we'll be getting this one 4t cos theta upon rho g to d for the height of this. Got it? So now let's continue with this part. So now here theta is 0 degrees. So since theta will be your 0, I'm convert writing rather than cos 0, I'm writing 0 here. So from this, just solve now regular algebra there. How will be solving algebra? 4t is equal to cos 0 is 1. This is your 1. Remember, cos 0 is 1, trigonometric relation. So 800 into 9.8 into 0.02 into 0.015 there upon cos 0, that is 1. Okay. And now if you'll convert this, so from that again one more point, if you want to find t, you'll be dividing t. I'm taking 4 below there. So rather than it will consider only t. That will be 1 into 4 there. And finally, you'll get t as 0.06. So 0.06 will be your answer. The attention, Newton per meter. Of course, the form and the unit will be Newton per meter. So from the options, what options they have given? So 1 kilonewton, that is not, this is not an option. This is not an option. This will be your option. Yeah. So 0.06 Newton per meter is the surface tension which we'll be getting for the capillary tube of diameter 2m at a specific gravity pointed where liquid is rising. The liquid rises in tube by 15 mm, making 15 mm. So what is the origin part here? 15 mm, making contact angle of 0 with the tube. Okay, right? Okay, thank you.